In 2017, something zipped through our solar system that no one could explain. Was it a rock or a message? Tonight, we follow the trail of Oumuamua, the stranger that made scientists question everything. Oumuamua arrived like a puzzle dropped into the middle of a physics lecture. On October 19, 2017, the Pan-STARRS telescope in Hawaii flagged an object moving fast and on a path that didn't belong to our solar system. At first, it was just another point of light, but within days, astronomers realized this visitor wasn't on an ordinary orbit. It was on a hyperbolic trajectory, unbound, passing through, and already on its way out into interstellar space. The first confirmed interstellar object to ever be observed in our skies. From the start, Oumuamua looked wrong. Its brightness flickered dramatically as it spun, suggesting an odd shape, long and thin like a cosmic cigar, or perhaps a pancake tumbling end over end. Size estimates varied, tens to a few hundred meters across, but whatever it was unlike the usual asteroids and comets we know from the solar system. There were more surprises. As Oumuamua swept past the sun, it failed to display the classic signs of a comet. No apparent haze, no obvious tail. Comets, heated by the sun, usually produce a coma, a fuzzy atmosphere of gas and dust, and streaming tails that telescopes can detect easily. Oumuamua remained stubbornly point-like, a hard glint in the sky. But the data kept delivering contradictions. After careful tracking, astronomers noticed that the object's motion didn't match gravity's predictions exactly. It was accelerating slightly away from the sun in a way that couldn't be explained purely by gravity. That tiny extra push was small, just fractions of a millimeter per second squared, but in precise orbital mechanics, that's a screaming anomaly. Something was nudging it. So scientists went back to the whiteboard and started comparing theories. The simplest explanation in science is usually the best starting point. Maybe the object was an oddball comet after all, releasing gas so faint that our instruments barely registered it. Even minimal outgassing can create a measurable thrust. But if gas was streaming off it, why didn't we see a coma? That unanswered question kept the mystery alive. Another hypothesis pointed to exotic composition. Could Oumuamua be made of volatile ices we rarely see, molecular hydrogen, for example, that sublimate invisibly, producing thrust without a visible dust cloud? Some lab experiments show unusual molecules can produce low-visibility outgassing, but evidence for such materials in an interstellar object is thin and speculative. Then came a more controversial paper that grabbed headlines. Avi Loeb and Shmuel Bialy proposed that the acceleration could be explained if sunlight were pushing on a very thin, low-mass object, essentially a giant sail. In short, a light sail. If Oumuamua were a naturally thin sheet, or even an artificial construct, radiation pressure from the sun could account for the small extra acceleration without any visible gas. It was a provocative idea, a possible engineered probe. That claim sparked thunderstorms of debate. Many astronomers pushed back hard. Why invoke aliens when natural mechanisms might explain the observations? It's an age-old scientific rule. Extraordinary claims require extraordinary evidence, and there simply wasn't direct evidence of technology. No radio broadcasts were detected, no bright beacon, no telltale pattern. SETI and other teams scanned the object with sensitive radio telescopes and found nothing that could be interpreted as a transmission. Silence. But silence doesn't settle the question. The object's shape and behavior remained difficult to reconcile with known rocks. Its light curves suggested extreme elongation or weird tumbling geometry. Its color, slightly red, resembled objects irradiated by cosmic rays for long periods, which fits the idea of a body that spent millions of years drifting between stars. That matches the idea that whatever Oumuamua was, it traveled a long time through the void before briefly visiting our neighborhood. Why are astronomers so excited by objects like this? Because they are messengers. Whether natural or artificial, interstellar interlopers carry information across light years about composition, dynamics, and the raw materials that build planets elsewhere. They are samples from other systems we cannot yet visit. Studying them helps us test theories about how planetary systems form, eject material, and sometimes fling debris into interstellar space. The controversy over Oumuamua also exposed another truth. Our technology wasn't ready. We had a narrow window, a few weeks to observe it before it faded beyond our reach. Follow-up opportunities didn't exist. Our telescopes were powerful but not designed to chase fleeting interstellar visitors. If Oumuamua had been an engineered object, it slipped through our hands before we could get a definitive answer. So scientists moved from arguing about this single object to planning for the next one. In the years since, surveys like the Vera Rubin Observatory, formerly LSST, promised to find many more interstellar objects earlier and closer. More detections mean statistics. We'll learn whether Oumuamua was a freak accident or representative of a vast population of interstellar travelers. And crucially, earlier discovery means longer observation time and a better chance to point multiple instruments, from radio arrays to infrared telescopes, at a newcomer while it's still within reach. Let's be clear about what we do know and what remains open. We know Oumuamua came from beyond the Sun's gravitational pull, its motion hyperbolic and unbound. We know it displayed a surprising light curve, implying an unusual geometry. We know it lacked a clear cometary coma in visible light, and we know it showed a small non-gravitational acceleration. Those are hard facts, each measured by different teams with different telescopes. What we don't know is the cause of that acceleration. Outgassing, radiation pressure, something stranger? Each explanation has challenges. If outgassing, why no visible coma? If radiation pressure, how did such a thin structure, natural or artificial, survive interstellar space for millions of years? If artificial, why no signals? Each path raises more questions than it answers. That unresolved state is a powerful driver of science, not its failure. Controversy led to better models, more targeted observations, and new strategies for future detections. It forced scientists to be precise about what claims they can justify and cautious about what they cannot. Beyond the hard science, Oumuamua sparked something else: public imagination. It became a symbol, for skeptics, of premature sensationalism, for curious minds of possibility. For many of us, it reignited a very old question: are we alone? Even without a smoking gun, the mere fact that interstellar objects pass through our system and that we can now detect them makes the discovery of life elsewhere a practical, testable question rather than pure speculation. In the coming decade, the balance of evidence will shift. New instruments will find new interstellar visitors sooner. If we catch one on approach, we could mount rapid, coordinated observations across the electromagnetic spectrum. Maybe we'll even design fast missions, small probes pushed by advanced propulsion to intercept the next neighborly interstellar rock. The technology is conceivable. The appetite is there. For now, Oumuamua remains science's elegant tease, a single, strange traveler that forced our best minds to stretch their explanations. Whether it was a battered shard of cosmic ice, a tumbling chunk of alien geology, or, and this remains the most sensational hypothesis, a purposefully sent probe, it did something priceless. It reminded us that the universe is stranger than our current models, and that curiosity, rigor, and skepticism together are the tools we need to sort myth from reality. So what should you take away from the story of Oumuamua? First, science is a process, not a pronouncement. The object was observed, measured, debated, and it changed the questions scientists ask. Second, the cosmos is now knocking at our door in new ways. Interstellar visitors will become more common in our data sets. And third, the search for answers, whether mundane or mind-bending, is ongoing and far from over. If you want to follow the next interstellar visitor with us, hit subscribe and ring the bell. We'll be there the day the next strange object appears, telescopes pointed, antennas listening, and minds open to whatever the universe decides to show us.